Hello and welcome to today's lesson on standards 2.2b and C in Algebra 2. And it's also going to cover questions under the study island topic, systems of equations and inequalities. This is part 2 of 2 videos that talk about these questions and topics. And so you want to make sure that you watch both of them before you attempt any questions in study island. This video is going to deal with the systems of inequality, so they're just going to be like the lines on there's going to be some shading, and then we're also going to have systems that have quadrilaterals in them, so that's going to have some of the U-shaped graphs in them too. But just remember all of your study tips and you'll do fine. Make sure that you're taking notes, and you can pause before and rewind if you need to catch up, and you can even pause before a question, see what you think the answer is, and then check yourself so that you can learn from your mistakes if you have any, or learn that you're doing pretty well. So I'm so glad that you're here, and let's go ahead and take some notes.
We are graphing linear inequalities. It's just like graphing lines where you use the slope and the y-intercept, but you're going to have to remember 2 additional things. You're going to have to remember when to graph it as a solid line and when to graph it as a dashed line. So it's a solid line if it has the equal to part, if it has that solid line in the symbol. It's a dashed line if there's no equal to part, if it's just greater than or just less than. And then the other thing you're going to have to remember is the shade. You're going to shade above the line when it has greater than in your symbol, and you're going to shade below the line when it has a less than in its symbol. So here it gives us the 4 graphs to pick from, and then it gives us the system of linear inequalities to match it to. So here I have a greater than or equal to part, and that means it's going to be a solid line. So I'm looking for a solid line that has a y-intercept of -4 and a slope of positive 1/3. So if I look here, that's a solid line, that's a solid line, that's a solid line, that's a solid line. So that's all correct. And I'm looking for a dashed line that goes through +2 and has a slope of -3. So that's a dashed line, that's a dashed line, that's a dashed line, that's a dashed line. So that didn't help me narrow anything out, but sometimes it does, so it's good to check. So my solid line is greater than, so that means I'm going to be shading above my solid line. So here's my solid line, and the green is below that. So that means W cannot be a choice. Okay, so here's my solid line, and the shading is above that. So that could be a possibility. We'll have to check the blue also, but so far so good. Okay, so here I have my solid line, and it's shading below again. I need it to be above, so it can't be Y. And then here's my solid line, and it's shading above, so it could be Z. So let's look at my second equation is a dashed line, and it's also a greater than. So I need to be shading above my dashed line also. So here is my dashed line. Well, this one it's shading below, so it can't be X. And then Z, here's my dashed line, and it is shading above. So Z is definitely going to be my answer. All the pieces fit together. So C is my final answer. Okay, so this one here, it gives us a system of inequalities, and it wants to know where is the solution for that system. The solution is going to be where it's double shaded. So you're going to need a piece of graph paper for this one, and then you're going to want to graph these. So the first one here, I'm going to do in purple, and it has a y-intercept of 3. Remember, the y-intercept is always the number by itself. And it's going to have a slope of -1/3. So that means I'm going to go down 1 into the right 3. So down 1 into the right 3, I get a point there. Down 1 to the right 3, I get a point here. And you can go backwards some too to help you to draw a straight line. And then this one, it has a greater than or equal to part. So that means it's going to be a solid line, and I'm going to shade above. So I'm going to go ahead and draw my solid line, and I'm going to shade above that. And then I'm going to go ahead and do the second one, and I'm going to do that one in blue. It has a y-intercept of -1. So I'm going to draw a dot at -1 on the y-axis. And then this one has a slope of +3/4. So that means I'm going to go up 3 into the right 4. Up 3 into the right 4. And you're going to draw the straightest line as possible. I'd highly recommend using another paper as a straight edge. And this one's also a greater than, so that means this line actually needs to be dashed because it's just the greater than. And then it also means that I'm going to be shading above. So where those two graphs overlap is the solution. So where there's purple and blue, that's where I'm going to shade in just the green. And it's that part there that is going to be your solution. So my green is in quadrants 1 and 2. So that means my answer here is going to be A. So here they give us a set of equations and ask us to match it to the graph. So one way you could do this is if you had a graphing calculator, is you could just put these into your graphing calculator, graph them, and then see which picture looks the same as what's on your graphing calculator. But if you don't want to do it that way, then you're going to have to factor each of these. So this top one here is going to factor into x and x minus 2. So basically I'm just dividing out an x and factoring that out. And so here I can find the x-intercepts by setting each of those pieces equal to 0 and solving. So that first one's already solved for 0. You're going to have x equals 0, and then you're going to have x equals 2. So that means for this top graph, it's going to have an x-intercept of 0 and 2. And because it's a positive x squared, I know that that one's going to be my smile. It's going to be an upward U, so it's going to be one of these red graphs. So I need my red graph to cross at 0 and positive 2. Well, W, it crosses at 0 and -2, so it can't be W. X, it crosses at 0 and 2, so I'm good. Y, it crosses at 0 and 2, but I'm good. Z, it crosses at 0 and -2, so it can't be Z. Okay, and then I'm going to go ahead and do the same with my second equation there. I'm going to go ahead and factor out an x, just like I did before. And that's going to be negative, I'm going to make that the negative x plus 3. And then I'm going to set each of those equal to 0 to find my x-intercepts. So here x equals 0, and here x equals -3. And because this was a negative x squared, that means it's going to be a frown. It's going to be an upside down U. So I need my blue upside down U and these answer choices to cross at 0 and -3. So here, x, it crosses at 0 and -3, so it's most likely going to be my answer. Let's just double check y. It crosses at 0 and +3, so it can't be y. So that means it is x, and my final answer is D. This problem's similar, only I have a line and a U, a line and a quadratic, instead of two U's. So here, same thing, you could put this in your graphing calculator and just graph it, or you can look at the equations and figure out the graphs that way. So here, this is my line, because it doesn't have a squared. It's going to have a y-intercept of 2 and a slope of -1. So looking at my lines, they all cross at 2, but some of them are steeper and some of them are flatter, so that means they have different slopes. Let's find the one that has a slope of -2, so that -1/2. So that means I'm going to go down 1 and across to the right 2. So here it goes down 1, and then over 1, 2, and the graph is there. So W has the right slope. Here 2, I'm going to go down 1 to the right 2, and there's no graph there, so it can't be X. And so the same thing with y. If I go down 1 and across 2, that puts and the graph needs to be there, and it's not, so it's not going to be y. And then z, if I go down 1 and over 2, my line graph is there, so it could be z. So now let's look at our quadratic. So once again, I'm going to have to factor that, and this factors into x minus 1, x minus 1, and I'm going to set each of those equal to 0 and solve to find my x-intercepts. So here, x equals 1 and x equals 1. I get the same answer. That's fine. That just means that my u is only going to touch the graph at positive 1. So in this one here, in w, it's touching it at negative 1, so it can't be w. In z, it's touching it at positive 1 and only positive 1, so that's good to go. So that means my answer is going to be z, and my final answer is choice A. So here they're asking us to actually solve the quadratics. So one thing that you could do is you could graph these and then see where they intersect, and those points, whatever 2 points those are, would be your answer. If you need to do it algebraically, though, both of these are already set equal to y. So since they're equal to the same thing, they're also equal to each other. So I can take x squared minus 3x minus 6 equal to 2x squared minus 12x plus 14. And I'm going to solve this equation for x. So it's a quadratic, so I'm going to have to set it equal to 0 first. So because the higher coefficient on the x squared is on the right, I'm going to bring all my left terms over to the right. So that means I'm going to have to subtract x squared from both sides, and I'm lining up like terms. I'm going to have to add 3x to this side, putting that under my other x term, and then add 6 to both sides. So on this side, these all cancel out, and I'm left with 0, which was the hope. 2 minus the 1x squared is a 1x squared, or just x squared. Negative 12 plus 3 is a minus 9x. And then 14 plus 6 is a plus 20. And so now I can choose one of my ways to solve quadratics, whether that's graphing, completing the square, quadratic formula, or factoring. I'm going to go ahead and factor this. This factors into x minus 4, x minus 5, and that's equal to 0. And then to solve this, I have to set each part here equal to 0. So x minus 4 equals 0 and x minus 5 equals 0. I'm going to add 4 to both sides on the first one, and that gives me an answer x equals 4, and I'm going to add 5 to both sides, and that's going to give me an answer of x equals 5. So those are my x coordinates. So that's going to rule out letter A. So B, my x coordinates are 4 and 5, C, my x coordinates are 4 and 5, and D, my x coordinates are 4 and 5. So that means I'm going to have to go ahead and substitute these answers into one of these equations to find out what y is. I'm going to pick the top one because it just has smaller numbers, but you could pick the other one. So I'm going to have y equals, and I'm going to go ahead and do it for x equals 4. So anywhere there's an x in this equation, I'm going to substitute in 4. So I have an x squared, so I'm going to write 4 squared, minus 3 times x, or now I know that's 4, minus 6. So I'll go ahead and simplify this. 4 squared is 16, minus 3 times 4 is 12, minus 6. 16 minus 12 is 4, and 4 minus 6 is negative 2. So y equals negative 2. So that was for when x is 4. So that means that coordinate is going to be 4, negative 2. Which the only way you see that is B. So that should be my answer, but it's always a good idea to check to make sure you didn't make a mistake somewhere. So let's go ahead and look at what it would be for x equals 5. So I'm going to do the same equation up here. I'm going to have y equals, and I have an x squared, but this time x is 5, minus 3 times 5, instead of that x, minus 6. And then 5 squared is 25, minus 3 times 5 is 15, minus 6. So 25 minus 15 is 10, minus 6 is 4. So here y equals 4, and that was 4 when x was 5, so my coordinate here is 4, 5, which is the other coordinate in B. So I did do a correct job, and that is going to be my final answer. Okay, this problem is very similar, only now I have a quadratic and a line. They're both equal to y, so that means they're equal to each other. So I'm going to set x squared plus 5x minus 25 equal to 4x minus 5. And I'm going to solve this for x. And since it's a quadratic, the highest power is a 2. I have to set these all equal to 0. So that means I'm going to subtract 4x from both sides and add 5 to both sides. So I lined up like terms. Here, these both cancel. So that means it's set equal to 0. Here I'm going to have x squared. 5x minus 4x is 1x, or just a plus x is the same thing. And then minus 25 plus 5 is a minus 20. So once again, you can choose how you want to solve this. I'm going to solve this by factoring. And it's going to factor as x plus 5, x minus 4 equals 0. And then when I set each of these equal to 0, x plus 5 equals 0, that means x is going to equal negative 5. And then x minus 4 equals 0, x is going to equal 4. So that means I'm going to have a negative 5 and a positive 4 for my x coordinates. So A doesn't have that for its x coordinates. Negative 5, 4. Okay, B does. My x coordinates in C are 5, negative 4. So that's not correct. And then D, my x coordinates are negative 5, positive 4. So it could be D also. So I'm going to have to substitute in these values of x for y. And I can pick either one of these. I'm going to pick the linear one because it doesn't have an x squared. So I'm going to have y equals 4x, but instead of x, I'm going to do a negative 5 minus 5. 4 times negative 5 is negative 20 minus 5. And negative 20 minus 5 is negative 25. So y equals negative 25 when x is negative 5. So that means my coordinate is negative 5, negative 25, which is only in D. So that should be my answer. Let's go ahead and check it when x is 4 also. So here I'm going to substitute it into my linear equation. So I'm going to have y equals 4x, but now I know x is 4, so I'm going to put in a 4 instead, minus 5. 4 times 4 is 16, minus 5 is 11. So y equals 11 when x equals 4, so my coordinate is going to be 4, 11, which is the other coordinate in D, so that's definitely my final answer. I hope you learned something new today, and I'm really glad that you joined us.